Hey guys, so in this tutorial or walkthrough, we will be creating a vanity from the image. It was actually something that I did for interior of a bathroom that I worked on a while back, so I thought it would be a good idea to kind of share the process of modeling this thing. It's a pretty simple, straightforward project, but I think we can cover some of the basics of modeling and modeling furniture and material creation. So let's get right into it. The way that I've structured this is basically there are some sped up parts 5 to 6 times, so you can check those out more carefully if you slow down the video, but other than that, the commentary parts will be in real-time speed, so you can follow along nicely. So right here I'm first importing the CAD files that I got from the client, and the vanity itself is pretty straightforward. It's sort of like a vintage looking wooden vanity with marble top, and wooden drawers. So here's an image of sort of a sample that they sent over, and it was more a sample of the marble material and the overall layout, of the top marble part. And so I didn't follow the image reference exactly as it is, but of course I was provided with these blueprints, that I base my modeling on. So the first thing I do is I actually just organize everything and create layers that just makes things easier. Switch everything from make one CAD layer and then make another geometry layer. That way I can switch things off faster. And you can see here I'm just starting off in the front view actually of the CAD that I got, and placing just these simple planes. So I generally start modeling in sort of like a 2D perspective. So first I define the flat surfaces, and then I continue on with making the depth, the thickness, and focusing on the edges and everything like that. So you can see that I also have a snapping, turned on. Makes things a lot easier in 3dsmax. You have this in other softwares as well. Blender has this too. So I really try to utilize it as much as I can. It generally when I have a CAD file, it makes things a lot easier, to work with. Also, sometimes when I receive these CAD plans from the client, there's some discrepancies between, like the elevation drawings and, for example, the base drawing where you would actually get your thickness from, unless you have like elevations from all sides. And if there's like differences in the dimensions and whatnot, I usually stick to the most the CAD that provides the most info regarding the dimensions. So in this case this will be the elevation part of the drawing, which I'm focusing on right here. And then I just follow everything up by defining the edges of the drawers right here. So I'm just connecting these edges and making these sections that will be easier to extrude later on as well. So once you make these sections that you need for the drawers, generally what I do is define the gaps between the drawers themselves. Something that will look nice in the render, be defined, but not too large. And here I'm actually using like the inset command in 3dsmax, which is very helpful. It has like 2 modes that groups the polygons and insets them, and then or you can inset individual polygons, such as here. But one thing to note when you're doing this, you can see that the distance between the actual drawers is not the same as the distance between the drawers and the outside of the vanity. So this is something that most of the time you just fix manually by selecting the vertices and then moving them in by the proper amount, So dimensions, I would say, in this instance are very important. You don't want to make these too big. I usually go somewhere around like 2 to 5 millimeters at the most. Any more than that, and the vanity would not look realistic in that way. So once I've made sure that all of these are correct, I just follow this up by selecting all of the polygons that will be the drawers, and just use a simple detach command, and move them in front. So I have a nice base for the sort of base of the vanity behind them. And in this instance, I actually had no use of creating actual drawers. I just needed the front faces of them, because I wasn't going to have any shots in the scene where I would actually need the drawers to be open, exposing whatever is needed inside. And this is true for most of the stuff that I do, unless a client specifically asks for part of the furniture to be like open or exposing something. I usually just stick to this method. And here, actually, since I have these drawers already defined, I'm applying the chamfer modifier instantly to them. And you want to have chamfers in your furniture models, but you don't want to overdo them in terms of the radius amount. Something like from 0 to 1 to 2 centimeters works best, for this. And you also might want to consider chamfering or filleting as well. It gives slightly a different feel to the image, and these edges, are important for the final rendering, because they catch the light nicely and make the model look overall more realistic. You will hardly see like totally sharp corners in real life, so that is something that you're supposed to follow through in your models as well. Another thing you might want to consider, as I'm doing here, is using a fillet together with a chamfer option. It also gives a really nice result. So you want to slap a chamfer modifier on top with the one segment, and then put another chamfer modifier over that with a bit more segments, to soften the edges more. And be sure to set the smoothing to chamfers only, unless you want to get like some artifacts on the large flat surfaces. For the creation of the pools of the cabinet, I was actually given freedom to model something that I thought would fit the overall look, So I went for a sort of a simple glass pool, and modeling this was pretty straightforward. You just create a cylinder with sufficient edges. I like to keep them in 32. This way you can subdivide them or turbo smooth them with modifiers, whichever you prefer. But I find that unless you have extreme close-ups of the furniture, you generally 32 sides does the job pretty well. You can't notice any artifacts, especially when you smooth the polygons the right way. So here I'm just making the glass part, and making sure that the segments, height segments, are turned off, because I don't really need those. And I'm just making another small copy that will be sort of a holder for the last part, giving it some slight, insets to make it a little more interesting. Like I said, this will probably not be visible at all, but it's just something that why not do while you're at it, Also, when you're working with these making copies and stuff, make sure they're actual copies, not instances, because I've had tons of time happen to me, like when you're copying these parts that are supposed to be you know, different, so supposed to be edited in different ways. I forget to, you know, make it a copy instead of instance, and then once you zoom out, it's a whole mess, you know, because every change that you made on that single geometry, it's just a change in the entire scene, so you have to go back manually and fix everything. So that can be a drag. Just make sure you're copying when necessary, and once you're done with the whole pull out the way you want it to look, you can apply materials to it, then you can instance it on the other pulls. Once I've instanced all of the pools, you'll notice that the chamfers that I created for the right section of the wooden panel, I did not apply to the other pieces. So one cool thing about 3ds Max, which is why I love this software, is that the modifier stacks are really powerful. I mean, you can copy and paste them, and it's sort of a semi-destructive workflow, I would say. You can't edit, well, sometimes you can get away with editing the lower modifiers, for example, edit poly, but most of the time it will mess up the overall look of the either ender. But right here, I'm just selecting the two chamfers and I'm copying to all the other elements here, and yeah, it makes really quick work. You can also paste special, which would be sort of instance pasting these chamfers, so that when you modify the chamfer on the main geometry, it will modify on all the other geometry pieces that you pasted the chamfer to. So that's also very helpful. But I usually avoid that because it's not a lot of work to go into each individual one and adjust it as necessary. And right here comes the part of actually modeling the marble piece of the vanity, and this is, well, I look at it sort of a one solid slab of marble. So I opted to go for a sweep kind of model, and here you can see I'm creating a profile curve. It's pretty simple. You just select the spline and roughly draw out what the profile would look like. And here, actually, when you right click or like drag these vertices that you've created, you can see 3ds Max is pretty finicky with these splines. So you have to go in, select all the splines and right click and make sure they're all corner or bezier, whatever it is you need. And what you also want to make sure is the interpolation option right here, because while adaptive works most of the time, you also have to be careful about the poly count. Adaptive mode might make the line too detailed, create too many vertices, and this will depend on what you want to do. Actually, do you want to subdivide the marble top part further on? If that's the case, then you can get away with the optimized lower res curve, and then which it's just gonna look fine when you turbo smooth or subdivide it. But here, since it's a pretty simple modeling process and a small furniture part, I opted just to use the adaptive mode. It's not a huge, doesn't take too much of memory or whatever to have a bit more polygons in here. Also, if you're getting any of these issues, as you can see here, that you can't actually move the beziers the way you want, you might want to check if all the vertices are in the same plane. You can see right here they're not, so I proceed to right select on the vertex and then make it a corner and then push it back where it belongs. 3ds Max sometimes does this when you're drawing, so it's always good to make sure they're all in the same spot. Otherwise, it will create problems if you want to, for example, sweep the the profile, or if you have a closed spline, it will create problems where you cannot place an editable poly on it, or like make a 2D object from it, because it's not a planar curve. Once that is done, I move to the top view and actually start drawing the line where the sweep that the profile will go across. Make sure everything is set up correctly, and like I said, there are several options when making this top, and you just have to see which one works for you. You can use this curve that I just created, and you can fillet the corners right away, so that the curve sweeps, along the filleted corners. You can use straight corners, and then once you made the sweep, you can put an editable poly on top of that and chamfer those edges in the geometry. I mean, the editable poly itself. It's just a matter of figuring out what works best, because sometimes you do get artifacts with these things, especially when you chamfer a lot. You need sufficient space between the edges to make the chamfers really work, which is another reason why you would need to make the sweeping profile curve a little bit, less dense. So here you can see once the sweep is done, and I've capped the top and the bottom geometry, I'm actually selecting these hard edges that are supposed to be filleted from the top view, and I'm trying to use the chamfer command. But as you can see, the chamfer command can be a little buggy sometimes. So this is basically, trial and error, seeing what works, what doesn't work. And I actually found this chamfer size to be a little bit too small for my liking. It's not noticeable at all when you zoom out, and it wouldn't allow me to push it any further with this method. So yeah, just goes to show that all of these things are trial and error, even with like the most simple models that you can create. You can see this the issue persisting right here. You can see I'm trying to figure out how to solve this issue, and actually, since I already have the profile curve, I'm just trying to lower down the steps, make these distances between the edges a little further, and just testing out if the chamfer works on them now. But you can see you're able to get away with a little bit more distance between the lines, but you still at some point get this sort of, the lines don't follow along the way you want to. And I'm just checking if this works from a distance, the fillet radius. This is something that looks okay. So after I've checked that the chamfers that I wanted did not work, here's another method where you can get nice fillets, chamfers, when using the sweep command. You can actually lower the steps here. It's not necessary, but you can actually edit the line that the sweep is happening on as well. And this is super powerful. So you select the line, select the vertex, and in the commands you just fillet the line itself, and it gives the desired result. You get a little bit of pinching on the top and bottom vertices once you do that, as you can see here. But that is something you can fix very easily. Once this part is done, we can proceed to creating the sink, and doing this is pretty straightforward. We just need to make it the size necessary from the base, and we'll use this geometry that we've created for creating the sink itself, and also creating a geometry that will boolean into the marble top. You can see here, once we've done all the chamfering and boolean and created the sink itself, you can see that we're having an issue with the intersecting geometry here. So the bottom of the sink is not visible due to the overlapping geometry below. And there are usually two ways I go about this. You can either cut the geometry, connect the edges, which I will do here, and simply remove the polygons that are creating the issue, or you can just decide, hey, this is not going to be visible in the camera when you're doing the render in the scene, whatever. So I'm just gonna completely push the entire element to the right as far as it can go, so it doesn't create this issue as well. It's not going to be visible. It's the inside of the vanity as well. So perhaps that's what I should have done here, but I'm just showing you that both methods work, without problems. If you, for instance, run into an issue where you have like a more complex geometry, such as this marble top with loads of vertices or whatever that's creating the issue, and you try to connect all these edges, create new edges that you can cut so the sink is visible, but you get these sort of artifacts because the edges and vertices are not all connected, and it's not sort of a quad geometry, which would make this easier. In order to avoid these artifacts and overlapping, manifold edges or whatever, you need to simply just put a slice modifier on top of that, and it does the cutting for you. And yes, you can see here, place it all. You can just copy and paste the modifiers on top of each other, define the slice planes, and once you do that, you can choose to collapse the stack of modifiers or not. That is up to you. But yeah, it just does the job the same way you would connecting the edges, but a lot quicker for more complex geometry. Stuff is pretty much, rinse and repeat. You create the geometry you want to boolean, make a hole in the sink, and then use the same geometry to create sort of a plug or something interesting. That's so it's not just a hole. This particular thing won't be visible in the camera in my scene at all. But if you're, for example, working on models to sell them, or working on shots from above, it's also an important step, to have this as realistic as possible. You can see here that I noticed that the sink is actually cutting through another part of geometry, the drawer below, And instead of going through the hassle of cutting everything up and boolean whatever the problematic surface, since I won't have the sink visible from above, I just chose to lift it up a little bit and sort the issue that way. So it's a nice little shortcut. When you can get away with it, you should definitely do so. Moving on to the marble front part of the vanity. For this, I decided just to use a simple spline and snap the vertices on the CAD that I already have. I think the lines will be sufficient enough, but if not, you can use this option as well. You can use the vertices on the sort of Beziered part to make him a Bezier corner, and it's just a quick way of getting the same result, but preferably if you need a smoother result, this is the way you can achieve it too. Just make sure that the adaptive mode is checked in the interpolation. And yeah, after you make this after you make this geometry, you can simply slap an added poly on top of it and give it thickness, add a shell modifier, and just mirror it to the opposite side. So right here I'm moving on to the creation of the faucet, and I'm not making it exactly as per the reference supplied, but it's going to be something similar, more of a vintage kind. And this is just a simple process, consisting of creation of simple primitives, and I'm actually going to be using a renderable spline to create the tap itself and the side pieces. Not sure what you call them, but yeah, I'm just going to be using the same principles. And for this tap right here, I'm just going to be using a simple lathe modifier, which is really helpful in these instances. So you just sketch out the profile spline, and you place a lathe modifier on top of it, and I have a hotkey set up here for viewing end result, so I'm able to go down to the line and toggle the visibility of the top modifier by pressing on a Q. So I think that's really helpful, because you get to see the way the end result looks. You know, you're just not fidgeting with the line itself, but with the geometry. And this is a trial and error process as well. It's good to look at some references for these pieces for the thickness of the turning part as well, to make it look, you know, realistic. For these smaller handles right here, I opted to go with the same approach, but I wanted to really have the regular sphere here, so I'm just using two splines to define which parts I want. And it's a simple trimming command within the splines that you can do. Just make sure to weld the remaining vertices that you've trimmed to make the lathe work after that. And so it's just simple lathing, creating these curves to be as true to life as possible. Make sure also the geometry is flipped the right way. You can do that in the lathe modifier, and it's just a matter of doing that and then placing all these in the arraying them, you know, along the main part of the tap. Once the modeling part is done, I make sure to attach all the necessary geometries that are going to have the same materials. And you can do or not, you can do this or not. I mean, it's just a matter of preference. But bear in mind that once you attach these geometries, they will lose the modifier stack in 3ds Max, so it won't be as editable. But another option would be just to simply group them together within 3ds Max as well. Here I will then actually start working on the texturing of this vanity that I've completed. And the first step in creating realistic and believable textures is finding a good HDRI map. And there are loads of these maps available for free online. You can also, of course, purchase them if you wish, but a good source for these would be I believe it's called HDRI Haven, and those are free for use, and there's some pretty cool ones. The way I choose these maps is based upon what my scene that the vanity is going to be placed in will look like. So I'm not going to choose like a studio HDRI map for a vanity that's going to be placed into into bathroom. You can see here that I chose a HDR map that's simple interior, and I've seen a lot of people use the same one, and it's a good HDR map because it has these bright exposure spots that really are able, when you spin the model in the right angles, they're able to showcase the specular on the model itself well, and I think that's very important. You can see here I'm just starting off with the basic gray material, and this is going to be the wood material, but I'm just selecting the parts that are going to share the same material. So you can either do that or attach them. Doesn't really matter all that much. For the wood texture, I'm just trying to find something that'll fit as close as possible to the reference of the material you provided, and I have loads of these that I've downloaded and purchased over the years. Yeah, just make sure that they're kind of high poly, and we won't be unwrapping this model. I don't think it's necessary for such a simple model. We won't go through that whole process of unwrapping, baking, and baking the high poly or whatnot. I'm just going to be using a simple Corona tree planer mapping style. I think it works pretty well. I mean, with the combination of the UVW, what do you call it? UVW randomizer, I think you're able to achieve pretty much seamless textures overall using the triplanar mode. So the way I'd make these textures, it's pretty straightforward. I just select the diffuse map, and usually when you purchase these materials you get the roughness or specular and bump or otherwise displacement map with the diffuse as well. And yeah, I just use those in combination. It's a simple material. There's no ambient occlusion, there's no wear and tear. It's a simple model for now. For the roughness map, you can see here that I've selected like a smudge map that I've placed into the Corona UV randomizer to make it to not make it seamless. I mean, to make it seamless actually. And I actually like spinning the model, rotating it in the viewport so that I get these nice reflections in the material itself. It's much easier to see what you're dealing with reflection wise that way, instead of facing the the material straight forward, for example, you always want to angle it a little bit, to get those highlights visible. And another option, I mean, you can also use the option to like turn on the reflection channel in Corona, which will help you visualize what your reflections currently look like. Right here, I like placing a output node between the to adjust the levels of the glossiness map, and this way you have a bit more control in the bright spots and dark spots, and the dark reflected points, and the parts that actually do reflect quite a bit more in the material itself. I usually tend to avoid super sharp and super contrasted glossy maps, because they tend not to look as realistic. But you can see here small adjustments, S-curve adjustments, give the best natural looking result. Once we've completed the wood material, moving on to the pools. This is also pretty simple. I already defined it as being sort of a frosted glass type, and this is a pretty straightforward material as well. What I do is set it up to be a completely refractive glass, put a little bit of roughness on it, so I don't use any extra maps for this. It's a small piece that won't be as visible, but the trick is to add a bit of scattering using the absorption. So you just pick a color that you like. In this case, I thought the black color, or perhaps I should have chosen a brown color, but the black color looks best with this. And you just sort of choose the color you want, and you adjust the distance for the density of the color right here. And yeah, I thought this looked pretty nice. The effect along the edge looked nice as well. You can see here actually when I turn the model to be very angular towards the light, I noticed that I had sort of a clear coat reflections turned down, and it was a bit too much. It was like a mirror reflective, So just tone that down a little bit and give it a more natural look. You should definitely always consult references for this. I mean, there's many different types of wood, but every material in essence has some sort of reflectivity. You just have to gauge how much of it you want, and what the actual finish is going to be. For the marble material right here, I opted to use the same option, just like the wood. So I found a nice seamless map of a marble that I can use, and it's pretty neutral in the pattern of the marble itself. So I just plug that into the diffuse and use a bit of color correction within the node itself to give it a little bit more punch. And yeah, this marble is not going to be that refractive. It has sort of a rough finish, and the rough finishes you can really achieve in two ways. You can go for the plugging of the roughness map, and then adjusting the reflection and reflection glossiness, or you can do if it's a rough material, you can find a nice bump map, plug that in, and once you increase the bump, the reflections are actually going to become more matte, and that is another way that you can achieve a similar result. And now once we've completed the marble, I mean, all we have to do is just texture the sink and the tap as well. So here I'm using a clear metal material for this cap. I mean, you can, if you have Corona render, you can of course use the presets that you have with the model, but sometimes I use those, but for the most part I just create my own small library. I'm not using it here because I wanted to showcase the process of actually creating the materials. And yeah, it's simple metallic sort of stainless finish. For the sink itself, I'm going for a more matted dark metal look. Pretty sure you guys know what material I have in mind for this. I'm not sure what it's actually called. But yeah, I just achieve it by setting the right amount of reflection and then adding a nice noise bump map. It's just a simple noise map with the correct size on it to give it a nice sort of a matte look. For the battery, I mean the tap, I'm actually going to be using the pretty much same material. I'm just gonna skip on the bump map here. I want sort of a stainless dark look, similar in the reference image. So it's just a small metal material, and yeah, I mean, it's pretty straightforward. You can see here I choosing sort of presets, but eventually, yeah, just select the right color. And this new Corona physical material is slightly different from the legacy ones we had before, in that when you create metal materials, the color really does matter. It sort of gives the can't have sort of an all black metal material and then have really nice reflections. If you have to play with the color a bit as well, as you can see here. So yeah, it's also important to have the right index of reflection set up, and yeah, Corona does that. I mean, this physical PBR materials have that set up automatically. So it's just a matter of just adjusting the color and roughness basically once you have the metal selected. And there you are, guys. This is pretty much the end result. I just did a little bit of visibility override in Corona, just to put everything on a gray background for presentation purposes. Here you can also see I'm playing a bit with the contrast, but I tend to do all these things in the scene when I import the model to the scene as well, because I already have sort of the LUTs and contrast and exposure set up there. And if the material or some texture looks washed out or too dark, then I adjust those things in the main scene as opposed to doing it in this scene that's just the model itself. So yeah, that's pretty much it. I want to thank you guys for watching this, and make sure to like and subscribe for more stuff like this.